Hello everyone. Today I'm delighted to introduce your sixth work, the multi-repetitions of single primitive for compositional zero-trust learning. Let's start with talking about what's the compositional zero-trust learning. The compositional zero-trust learning research aims to build a classifier for compositional labels, which contains two parts, the state part and the such as left, and the object parts such as the banana. While the classifier, which can be trained on states such as that's pizza, that's lemon, and unripe banana, peeled banana, need to classify the instance of less banana, which will never appear in the train data. So that's the reason why we call it compositional and zero-trust learning. So it's clear that the key point of compositional zero-trust learning is to understand how states like sliced interact with different objects that pizza, bread, and then generalize the interaction to banana or any objects. So here we meet the challenge called conditional variance. So this phenomenon describes a single primitive can have plenty of features combined with different primitives. For example, the old combined with tiger means the tiger is senior, while the old combined with building means the building is historical. Besides, we also can find the similarity between caramelized banana and ripe banana, even they both have the object primitive banana. The most common methods in compositional learning is to build a robust feature for each primitive, such as using a clipping cordon, and then the model learns to combine each primitive. But however, we consider that if a feature is robust, it may contain the intersection of each primitive. Well, if we want to generalize to unseen compositions, the unit size of each semantic meaning can become necessary. So here, we introduce this work called the MRSP, which contains a graph convolution network to compose primitives and use a three-branch cross-section model to decode from each visual instance. During training, the graph convolution network can learn how to compose each primitive, and during testing, we can decode state, object, and composition by three cross-attention branches. We evaluated method on three benchmark datasets. The information is showed in Table 1, and we chose two settings called the closed world and the open world. So, in closed world, the predict space only contains the compositional labels in this dataset, while in open world, the predict space is the Cartesian product of state primitive set and object primitive set. So we evaluate our methods with several previous methods in MIT states, labels, and closing. This result shows that our methods achieve best performance. And next, we want to know why our method can perform well by changing the backbone, removing some parts of the model, adjusting on graph convolution network and cross-section branches. We suddenly found that the backbone and the multi-repetitions are two key points which can explain the results. The unit of semantic meaning set is more robotic and accurate than the intersection semantic meaning set. After that, we show some retrieval results and visualization of the attention map. So finally, in this work, we introduce the multi-repetition of single primitive methods as a solution for compositional zero-trust learning. We evaluate our methods on several benchmark datasets and got the best performance. We also do ablation studies and visualization experiments. Our future work may focus on exploring more efficient approaches to multi-repetition construction and understanding. So that's all. Thank you.